that covers a problem type that's in your homework set. And the idea here is to convert a logic expression into a list of minterms or a list of maxterms. All right, so let's get started with that. All right, for me, when I look at this problem, my natural inclination on converting from Boolean functions to minterms and maxterms is to go to a Carnot map. But the exclusive OR makes this a little trickier for me. And so what I'm going to do is make a truth table. So we'll take A, B, and C. And implicit in the problem statement is the precedence of the variables. All right, so we're putting A in the most significant bit position, and C is in the least significant bit position. All right, so we can label these variables. And I always do a mental check. Do I have alternating zeros and ones in C? Do I have pairs of alternating zeros and ones in B? And then 4 zeros, 4 ones in A. So that looks right. Okay, I'm going to form this product AB as part of my truth table. And then for me, the exclusive OR is a little trickier, so especially when there's a variable that's complemented. So I'm going to go ahead and put the complemented variable here, and so that I'm not looking across a bunch of rows, I'm going to repeat the B column as well. You may not need to do that. And then I can calculate A bar exclusive OR B. And then from there, it will be straightforward to do A bar exclusive OR B ended with C. And then finally, I can get my function F. All right, so I have this truth table set up. All right, so let's start with AB. All right, so for the product of A and B, I'm looking where both A and B are equal to 1. So I glance through this list. That's pretty straightforward for me. And I can find where A and B are both equal to 1. All right, now I'm going to take A bar. All right, so complement all the A's. Then I'm going to repeat the B column just so that I'll have these adjacent to each other. 0, 0, 1, 1, 0, 0, 1, 1. And now, for me, this is an easy mental exercise to do the exclusive OR. All right, so I'm looking at 1 exclusive OR 0. That gives me a 1. Moving down the list, I can calculate the exclusive OR. All right, so now I need to take C and AND that with the A bar exclusive OR B column. All right, so C is right here. All right, and we are going to AND this column together. So I'm looking for the places where these two columns both have 1s. All right, so right here and here, and then here and here. So just those two locations is where you'd get a 1 there. All right, and so we can put 1s here and here. All right, so now we have that column. And finally, F is just the ORing together of this column, switch it, with this column. All right, so I OR those together. 0 OR 0 is 0. I have a 1 here. All right, so I have that, and now I can look at my minterm list. Okay, so this would be, starting here for the minterms, 0, 1, 2, 3, 4, 5, 6, 7. So I'm looking at, for this answer, Minterm 1, Minterm 6, and Minterm 7. All right, so that's the equivalent expression for this answer, 1, 6, and 7. All right. And so one of the things we talked about in class is that a Maxterm list is basically looking at the places where you don't have the minterms, all right? So once you have the minterm list, you can come up with the product of the Maxterms like we talked about in class. So everywhere you see the 0 is where you have a Maxterm. All right, so that's the inversion of where you see the 1s. Okay, so that would be location 0, location 2, location 3, 4, and 5. All right, so there's conversion of a logic expression to a list of minterms and Maxterms.